Hey everyone, welcome to the session by Intellipaat. Driving a data-driven business to success using tons and tons of data we have in today's world is a challenge, and big data analytics aims to do just this. IT companies ranging from the startups to the Fortune 500s like Apple, Google, Facebook and so many more require big data analytics. And in today's session, we are going to check out just that. Well, before we begin with the session, make sure to subscribe to the Intellipaat's YouTube channel to never miss an update from us. And here's the agenda for this session. We'll quickly take an introduction to big data analytics and check out why big data analytics is required. Followed by this, we'll check out all the tools that are involved in the world of big data analytics and the domains in which it's spread around. And followed by this, we're going to check out the use cases of big data analytics. And guys, if you have any queries, make sure to put them down in the comment section below and we'd love to help you out. And in case if you guys are interested in an end-to-end course certification, Intellipaat provides the Big Data Hadoop Certification Training Program where you can master concepts and earn a certificate in the same. So without further ado, let's begin with the class. So coming to the first point on the agenda, introduction to big data analytics. Well, so what is big data to begin with? The most simple answer that I can think of is that big data are extremely large data sets that may be analyzed computationally. And why is this done? Well, this is done basically to reveal all the hidden patterns, hidden trends and associations. This especially, relating to the human behavior and interactions. So at the end of it, when we talk about data, when we talk about big data, as literally the name suggests, it's a lot of data. And we need to filter through a lot of data to make sense of it is the most simple answer that we can come up with for what is big data. Then what is big data analytics? Well, as I just mentioned, it is basically the process of examining large and varied data sets. And this is basically done to uncover informations, again, hidden patterns, market trends, for example, customer preferences. All of this can be taken apart and, from the data, which is like very huge. So why should this be done then? Well, this is actually done to make sure that we help all the organizations take very good informed business decisions, because at the end of the day, if they're seeing terabytes worth of data, if they cannot make sense out of it, then it is not the right way to go. So, one quick thing that you guys need to know at this point of time is the difference between analysis and analytics. Well, analysis in its most simple terms is basically making use of past data and deriving some results from the data which is already present. And then analytics especially is something different. Well, we'll be using the data to obtain future insights, future trends, future details and so many things with respect to the data we have now. So this is a basic difference between analysis and analytics, guys. So, coming to know more about big data, again, the first thing you need to know is there's huge amount of data. Well, we're all aware of all the expenses of, storing and handling huge amounts of data, right? Storing data is extremely expensive and handling data is as expensive as well. And then coming to the uniqueness of the data, well, there is so many type of data if you think about it. There's structured data, semi-structured data, unstructured data, and then structured data can be, something in a table or an Excel format. Unstructured data can be something basically which goes on about videos, images and text which probably doesn't make sense as soon as you look at it, and so much more. Well, and all of these data come from a variety of sources as well. It might be Twitter's, it might be Facebook, and it might be data from across the world, across the globe, guys. And then the third thing is that you need to know that accessing and processing speed is another very big concern when it comes to big data, because let's say if you have 100 Mbps input-output channel where, you can process, and then you need to process 2 terabytes worth of data. So 100 Mbps is what your network is capable of doing, and then you need to go about processing 2 terabytes of data. And then basically this entire process of just for a small amount of data such as 2 terabytes of data will take you about 6 hours. Yes, it's going to take 6 hours for just 2 terabytes of data. But then now think about this. Let's consider the example of Facebook. Facebook has 2.3 billion monthly active users and counting, and this number is always rising. And this pretty much refers to 250 billion photos uploaded to Facebook ever since they came out, and then this equates to 350 million photos uploaded per day. So what did the data that Facebook generate? The people at Facebook generate 4 petabytes of data. Well, you can check out what a petabyte is. It's 1 followed by 6 zeros, and this is in gigabytes. So this is how much 1 petabyte is, and Facebook is generating 4 petabytes every single day. So think about imagining how you can go about handling all of this data, guys. And this brings us to the next case, which is again Instagram. And I'm sure most of us use Instagram out here. Well, there are 40 billion photos which are shared. 95 5 million photos every single day, 500 million videos per day, and this brings us to petabytes worth of data used and moved around per day. So what's a petabyte? Again, yes, you pretty much checked out a petabyte is. Just a quick info guys, if you guys are planning to get certified, then Intellipaat provides the Big Data Hadoop training program where you can master the concepts thoroughly and earn a certificate in the same. More details are given in the description box. Well, now let's get back to the session. So again, as we checked out, a petabyte is 1 followed by 6 zeros in gigabytes, guys. So this is a lot of data for a social media platform as well. And then coming to Twitter, every single second there are 6,000 tweets. This pretty much equates up to 500 million tweets a day, and this takes a huge amount of skill to handle huge amounts of data basically, and then they see terabytes worth of data every single day as well. So again, 1 terabytes is 1000 gigabytes, and then think about all the complexity that a simple tweet does and how Twitter goes on about analyzing it, storing it, and maintaining the data as well. And this should bring us to why big data analytics is actually needed. And I can give you 5 very important reasons of why handling big data is extremely important. The first thing is revenue generation. As we've already talked about, data, storing data and processing data can be extremely expensive. And if we can go about saving money there, then it is pretty much as good as, generating very good revenue for the company in terms of cost cuttings and saving as well. And then effective marketing. Well, effective marketing in the terms of making sure that your data is very structured and a lot of people get to know about it, and at the end of the day the data you handle or process should be easy enough such that it can be marketable and understood by your customers is again a very big thing about big data analytics. And then providing very good customer service, because you have lots of data where you can perform lots of analytics on that data and then give your customer a very customized experience. And this again is another important aspect of this concept. And then operational efficiency. Again, people say time is money. I think in the world of computer science, it's data is money, because at the end of the day, the better your data is for a data-driven company, the more efficient you become. Well, this pretty much refers to operational efficiency. And then it comes to competitive advantages. Again, this point can be elaborated beyond measure, but to give you the most simple aspect of what competitive advantage is, again, when you can think about all the data being handled by the social media companies that I just told you about, Facebook, Twitter, Instagram, and so much more, then think about how you can have an edge over the others by understanding data better, performing better analytics on the data, and taking over that number 1 spot or the podium spot, in the top fight of the companies, guys. So that provides again a very good edge in terms of competitive advantage. So elaborating on this again, in terms of revenue generations, again, when you can, think about technologies such as Hadoop, cloud-based analytics, and all of these basically bring very good cost advantages, because it helps in storing large amounts of data, and it does so by providing efficient ways of eventually storing the data, performing analytics, and doing business, guys. Well, if you do not know what Hadoop is, I'll be telling about it in the next couple of slides, so make sure you stick around for that. And then the next point is very important: decision making. Again, with the speed of Hadoop and in-memory analytics combined with the ability to analyze new sources of data, all these businesses, they're able to analyze information as soon as they get it. And this basically, again, saves time, helps them make a better decision, basically using all the things that they've actually learned. And this leads to new products as well. Well, you can know what your customer wants at this point of time, and you can provide the customized experiences I just told you, using the power of analytics, guys. So again, basically with respect to big data analytics, more companies are creating new products to meet customer needs all the single time, every single day in any of the data-driven businesses, guys. So this brings us to the tools which are basically essential in the world of big data analytics. Again, as I've told you, we have Hadoop, we have Hive, we have Storm, Cassandra, Spark, MongoDB, and various other tools. And these are the big guys and the big guns, as they would say, in the field of big data, guys. So coming to Hadoop. Hadoop is one of the very well-known big data frameworks. So it's basically from the Apache Software Foundation. Well, what it basically does is it allows distributed processing of huge amounts of data set across a cluster of computers, guys. So this basically tells you that you can split your data instead of storing it all in one machine, and you can spread it across n number of machines that you want over a network, or a cluster is the exact term. and then you can use it later, guys. So this makes up the distributed processing part of it, and it is designed to scale up from one server to thousands of machines as well. So if you're using Hadoop, you can go about using it on one machine as well as a scale up to thousands and more as well, guys. And this brings us to Storm. Storm is again another free and an open source big data computation system. So Storm is basically very efficient at handling a lot of data and helping processing data as well. But where Storm has a strong footing is that it can provide you very good analytics in real time, and it has amazing fault tolerance capabilities. With real time computation capabilities, at the end of the day, having these both are very essential because it takes a lot of power, it takes a lot of time and energy to build a system which will give you real-time processing, because we're talking about data in terms of terabytes, petabytes, and so much more. So if you can pick up something from that in real time and give it out, then it is amazing, right? So next up we have Cassandra. Well, Apache Cassandra basically is a database tool. It is actually very widely used to provide effective management of, again, large amounts of data, as we have been stressing for a while now. And then this again supports scaling. Well, how does it do that? Well, it supports scaling by performing replication of data across multiple data centers, and this is basically done for scalability, guys. And then extremely good fault tolerance and very low latency. So it might not be near real time, but it can be very good low latency in terms of working with Cassandra. And then Hive is another very famous tool which is widely used as well. Hive is basically another open source software, open source big data tool. It allows programmers to analyze large data sets which are present on Hadoop, and then it helps with querying, managing large data sets. Hive talks to all our database tools as well as Hadoop, and we can consider Hive to be the middleman when we are going about analyzing and querying datasets, guys. So this brings us to Spark. Just a quick info, guys. If you guys are planning to get certified, then Intellipaat provides the Big Data Hadoop training program where you can master the concepts thoroughly and earn a certificate in the same. More details are given in the description box. Well, now let's get back to the session. I am sure many of us here have heard of Spark, right? Well, you haven't. This is what it does. It is basically another open source big data tool which came into picture to fill the gaps of Apache Hadoop when it came to data processing, guys. So there are some advantages of Spark when it directly related to Hadoop, and then Spark was the clear winner out of it. But then Spark has its own use cases and Hadoop has its own. So what does Spark do? Well, Spark at the same time can handle both batch data processing, where data is split into batches, and then you can analyze and process each batches, and then it supports real-time data processing as well. And then Spark does something which is amazing, what we call as in-memory data processing. So it basically stores everything in memory and does not have to talk to a hard disk every single time. So what this does basically is it exponentially speeds up the data processing, guys. So this is one thing I really like about Spark, which is the in-memory data processing feature it provides to us as users. And then coming to MongoDB. MongoDB is again a very famous tool. Well, MongoDB is basically another open source NoSQL database, and it is cross-platform compatible as well. So cross-platform compatibility is extremely vital in the terms of big data, as we have lots of tools apart from all the ones that I've mentioned as well. So making sure that you can make all of your tools talk to all the operating systems, talk to all the clusters, all the nodes, it is extremely vital. And then MongoDB has a plethora of features as well, guys. So who should use MongoDB? Well, MongoDB is ideal for businesses that need really fast and real-time data analytics again, and this is basically required by businesses who have to take instant decisions at that point of time, guys. And it is also ideal for the users who want a very good data-driven experience from the excess or lot of data that they or their business has. So this brings us to the domains in which big data analytics has its foot deep, guys. And the first big arena, in my opinion, out of the 6 arenas we'll be discussing is in the world of life sciences. Well, we already know that clinical research and in the field of medicine, sometimes research is very slow, and it can be an extremely expensive process as well. But with respect to big data analytics, we can bring in a lot of advanced analytics, artificial intelligence, and we have something called as IOMT as well. It's basically Internet of Medical Things, and all of these along with all the data unlocks the potential of improvising speed and efficient to such a vast level that it is actually providing exponential results. So how was this done? Well, this is done by pretty much delivering at the end of the day more intelligent, automated solutions by making use of data and just by knowing how we can handle lots of data at the same time, guys. So the second arena where handling big data is essential is in the world of banking, because when you come to think about it, banks have a lot of data about a lot of its users, a lot of customers, and so much more. So when they gather and when they access all of these analytical insights that you can provide from large volumes of data, and this at the end of the day, if it helps them make a very good financial decision based on that. Well, let's say the bank expects customers to walk in at 9:30, hence they open the doors at 9:30, but then they don't realize that they're losing customers who might want to come at 9 a.m. as well. So with the data that you can have, unstructured data like this especially, they might drive so much more business if they were open at 9 a.m., which was just half an hour before. So that was a very simple example, but then when you talk about security in the world of banking, this is where analytics is required as well, guys, because this will give them access to all of the information that they think they need at that point of time as well. And this is done by, again, we'll be eliminating a lot of redundant tools in the world of banking, a lot of redundant systems will be gone, and then we will reduce overlapping as well, guys. And this brings us to the third arena. The third arena is in the field of manufacturing, because when you come to think about it, manufacturers deal with everything from complex supply chains, motion applications, labor constraints, and equipment breakdowns all at the same time as well. And this makes big data the most essential thing in the field of manufacturing industry, because when you're talking to multiple teams, when you're talking to multiple requirements at the same time, a lot of data can bring in a lot of clarity there as well, guys. Because again, when you come to think about it, it has allowed a lot of competitive organizations to basically discover all of these new cost saving opportunities and methods and revenue generation techniques, which was pretty much not there before, just by making use of big data analytics, guys. So again, the next arena is in healthcare. Well, again, when you can think about it in terms of healthcare, think about the data which is generated, because again, there is lots and lots of patient data, health plans, insurance informations, and all of these at the end of the day can eventually be difficult to manage for hospitals or any other healthcare industries as well, because having a very key insight on all of these after your analytics has been applied will make it so much simpler. And this is why, again, that big data analytics technology is extremely important in the world of healthcare as well. By analyzing these huge amounts of information with terms of any amount of data, guys. When you can think about it, it can be something very small or very huge, but then the data here is where it differs, is that the data can be structured or unstructured as well. And if you can do all of these quickly, then healthcare providers can pretty much go about providing diagnosis which can be life-saving, or treatment options like at the instant as soon as it's required. And this again makes the field of healthcare extremely efficient and exponentially faster as well. And this brings us to the next arena, is governance, guys. Again, when you think about the challenges that most of the governments face, it's basically to tighten down on a budget without compromising on any sort of quality or productivity for its nation. And this sometimes can get pretty troublesome, because there's a lot of law enforcement agencies, and again, they're struggling to bring crime rates down, because they do not have any resources to basically begin working with. But with the help of big data analytics, you can basically streamline all the operations while giving the agency a more holistic view, a more good overview and in-depth view of all the criminal activity, and then they can focus on the things that's required with the amount of resources they have, instead of just spending the resources on everything that at the end of the day might not be helpful. And this brings us to the next sector, which is in retail. Well, the people who are selling the products, what we call as the retailers, they know what exactly the customer wants and what exactly the customer needs. Well, and if they do not know, well, the shoppers know it for sure. But if you're a retailer who's armed with extreme huge amounts of data from their programs like customer loyalty programs, analyzing customer buying habits, and lot of other sources, they not only have basically an in-depth understanding of their customers, but they can use all of these data to predict the trends, recommend new products, and boost profitability, which is the most important point, the most important driving aspect of a retail business, guys. And then this quickly brings us to the use cases of big data analytics in today's world. Well, this is one of the amazing use cases that I pretty much could think of. Well, think about the big data architecture architecture for, well, think about this. The next time you go on Amazon Prime or say Netflix or any other streaming program, well, video recommendation engines are something which work so subtly, they are so subtly integrated that we do not even feel that the recommendation engine works. But then sometimes we are taken aback because the recommendation system is so good. So we'll just be thinking of, let's say, hey, I want to watch a comedy movie today. But then at the same time, or let's say you're browsing a couple of comedy movies, and then using big data architecture, these very good video recommendation engine then gives you amazing recommendations for a next comedy movie which you thought you wanted to watch just now. So that is something amusing, and you'll be like, wow, this was exactly what I was thinking, and my computer presented this to me. So basically, in terms of big data analytics, we can go about achieving very good results in terms of video recommendation engines as well. So we all have set-top boxes, we all have subscriptions to all these very good streaming websites, and here is how big data works there. Basically, what we'll be using is, we'll be using an open source Hadoop architecture as the big data foundation, and this is done to collect very raw user data from all of these on-demand videos, set-top box activity logs, scheduled recordings, media catalogs, your past recommendations, your past viewings, and so much more. And all of this is taken, all of this is processed and analyzed using the Hadoop framework, guys. And at the end of it, basically, we feed all these results into a search engine, which then delivers what we call as these unique recommendations to a user who's actually using the browser interface. And this gives you a tailor-made experience in terms of video recommendation engines, and this is the best part about a big data, in my opinion, guys. And you can quickly check out the architecture of how this goes about on the right hand side of your screen as well. So you have all of the data which gets into Apache's Hadoop, and then after Hadoop we're gonna separate it into Memcache and search engines, and then we have web applications and APIs. At the end of the day, what the user sees is the web browser, mobile web applications, or so many things which is basically used to share the data, use the analytics in the backend, and give your customer the tailored experience, guys. So this brings us to the next amazing use case of big data, basically, which is used to hire candidates as well. We all know if there is a job opening, there will be a lot of people applying. So if the company is hiring for 2 people, I'm not sure they just taken 2 people for the interview process. There can be people ranging from 20 to 200 to 2000 or more applying for a job. Well, if you can automate this process of making the job of a hiring manager easier, then you can go about using big data analytics for the same, guys. Well, we'll be basically looking beyond all the normal keywords you would see in a resume, and we would go in depth into what we call as semantic analysis, and we'll be looking towards both structured and unstructured content as well. You can pick up exact details, exact metrics, such as all the job titles the person has had, experience, certifications, industry he or she has worked in, the companies, all the skills he or she possesses, and so much more. And all of these you can pretty much take and directly compare it to a job description without the help of a human. And that's the most important thing, guys. And then you can go about further evaluating if the person is fit for the job in terms of the recruiter's perspective, including all of the hiring data, preferences, salaries, organizational metrics, and so much more. So pretty much you can go about filtering candidates by just by making use of big data analytics, guys. So you can take out all the candidates metadata, candidates files, job metadata, job files, and you can use the process of ingestion to basically bring all of these into your architecture, into the big data framework, and then make use of all the processing, searching, and matching engines, and then at the end of it give very good business application service. And at the end of the day, this can be sent to a web browser where the person might see the candidate or the person who's hiring as well. And then this brings us to the next use case, which is basically detecting insurance fraud. Well, we already know that a lot of insurance frauds happen. Well, it might not be a genuine case where a person is trying to claim the insurance, and sometimes it is very essential for the insurance companies to determine if it is a fraud attempt or if it's a genuine attempt. So this is done by basically, taking in all the information from the interview notes, email conversations, social media sites, and then they go about combining all of these data, unstructured data basically, with official structured records and transactions and transcripts of how it should be done. And at the end of it, we can compare the trends, we can detect patterns in which the user thinks. So you can think about online shopping, media viewers, or so many things at this point of time to understand how the customer thinks, how the customer tends to do something. and how we can go about detecting patterns in the person's behavior, guys. And what this basically does is it helps us identify hidden relationships throughout the person's behavior, and then we can go about using this to perform very good data correlation, network analysis, and so much more. And this again helps in sourcing multiple content repositories of public records, which is basically used to find rules, and all of these rules, if they are being voided, then it is what we call as red flag patterns. It means that this person is committing a fraud and it is not a genuine attempt to claim the insurance, guys. So basically we'll be you'll be using all the claim files data. Your big data framework will be basically computing your fraud indicators, and you'll be having a lot of data warehousing techniques as well, application APIs, and at the end of it again web browsers, where basically you'll be seeing the output as well of this, guys. Just a quick info, guys. If you guys are planning to get certified, then Intellipaat provides the big data Hadoop training program where you can master the concepts thoroughly and earn a certificate in the same. More details are given in the description box. This brings us to the end of this session. I hope you guys took away a lot of information from here. If you have any queries, make sure to head down to the comment section and let us know. We'd be happy to help at the quickest. On that note, have a nice day.